ever wished sending money was as easy as, sending an email? No banks, no waiting, no fees. That's kind of the dream with these decentralized payment systems. Ripple, for example. But how do you trust a system like that when there's no central authority in charge?
Yeah, that's where things get really interesting. So we're diving into this research paper today. It's called the Ripple Protocol Consensus Algorithm. We're going to try to unpack how it all works.
Awesome. And we'll make sure to break it down so everyone listening can follow along, even if they're not like total tech wizards. But, okay, so first things first. What are the the core challenges that any system like this has to solve, when you're trying to build a decentralized payment system?
Well, there are three main ones. You have correctness, agreement, and utility. And correctness, well, it's all about making sure the system can tell the difference between a real transaction and a fake one.
Right, because in the traditional setup, it's the banks that are doing that verification.
Yeah,
right?
yeah.
But now, in this decentralized world, who's checking?
Exactly. And that's where the consensus algorithm comes in, to figure out how to do that without a bank. But before we get into the nitty-gritty of that, let's talk about this idea of agreement, because everyone on the network, all the different servers or whatever, they need to agree on the order of those transactions and also the state of everyone's accounts.
Otherwise it'd be chaos.
Total chaos.
Yeah.
You could have people double spending, spending the same money twice. Or you could even have conflicting versions of the whole transaction history.
Yeah, so it's we're all got to be working from the same playbook, so to speak. No one can change the rules mid-game. But what about utility? What's that about?
Well, utility basically means making sure the system is, actually useful and usable. It needs to be fast enough so you're not waiting forever for your transactions to go through.
Oh, yeah, that makes sense. No one wants to wait a week for their money to transfer.
Exactly. And also, it can't be too complicated. It can't require some massive supercomputer to run it. People need to actually be able to use it.
So it has to be secure, reliable, and user-friendly. That's a lot to juggle.
Yeah.
Now, you mentioned this thing called the Byzantine Generals Problem earlier. What's that all about, and what does it have to do with Ripple?
Okay, so the Byzantine Generals Problem, it's this classic thought experiment they use in computer science. Imagine a bunch of generals, right? They're trying to coordinate an attack on a city, but they can only communicate with each other by sending messengers back and forth.
Okay, I'm following. Sounds kind of old school, but okay.
Right, but here's the problem. Some of those messengers might actually be traitors. They're secretly working for the enemy, and they're spreading false information to mess things up.
Gotcha. So some sneaky messengers causing trouble. But how does this relate to Ripple? I'm not seeing the connection yet.
Well, think of it this way. The generals, those are the servers in the Ripple network. And the messengers, those are the messages they're using to, communicate with each other and try to agree on transactions.
Okay, I see where you're going with this.
The problem is that some of those servers might be malicious, just like those sneaky messengers. They might be trying to disrupt the whole network or approve fake transactions.
Oh, so they're the bad guys trying to, cheat the system.
Exactly. And the Ripple consensus algorithm, it's designed to handle that, to make sure the system still works, even if some parts of the network are trying to pull a fast one.
So it's they built in this defense system that anticipates there might be some double agents in the mix. That's pretty smart. But before we dive into exactly how the algorithm does all that, let's just clarify some of the key pieces of the Ripple protocol, the basic building blocks. We keep hearing about these servers, ledgers, UNLs, and proposers. What are all those things exactly?
All right, good point. Let's start with servers. They're basically just computers that are running the Ripple software and participating in this whole consensus process.
So they're the individual players in this big financial game.
Yeah, that's a good way to put it. They're constantly talking to each other, sharing information, and, making decisions about transactions.
Gotcha. Servers are the players.
Okay.
What about these ledgers you mentioned? What are those?
Okay, so the ledger is basically a record of every single transaction that's ever happened on the whole network. Imagine a giant public accounting book, right? Open for anyone to see. It gets updated every time a new transaction is verified and added. So it's the complete history of every financial move.
So kind of like a public record of all the moves made in this game. No hiding anything. But you also mentioned something about open and last closed ledgers. What's the difference between those?
Oh, yeah, good point. Think of the open ledger like a working draft, you know? It's got all the latest transactions that have been submitted to the network, but they haven't been officially confirmed yet. So they're kind of like pending transactions, just waiting to be finalized.
It's like when you're waiting for a payment to go through, right? You know it's been sent, but it's not actually in your account yet.
Exactly. Now, the last closed ledger, that's the version that everyone's agreed on. It's the official record of the network's state, you know, at a specific point in time.
So that's the one we trust, the one we can be sure is accurate. Okay, got that. Now, what about these mysterious UNLs? They sound kind of intriguing.
Yeah, the UNLs, they stand for unique node lists. And honestly, they're kind of the heart of how trust works in this whole decentralized setup. So think about it this way. Each server gets to pick its own UNL. It's basically a list of other servers that it trusts, you know, servers it believes are reliable and honest.
So like each server has its own little team of advisors or maybe like referees that it listens to.
That's a great analogy. So when a server has to decide whether a transaction is legit or not, it only pays attention to the votes of the servers on its UNL.
Okay, starting to get the picture.
And the idea is that you want to pick a diverse group of servers for your UNL, you know, so they're not all likely to like gang up and cheat the system.
That's where it gets really interesting for me. It's not about like blindly trusting anyone. It's about building this system where you're smart about who you listen to, you know, diversifying your information sources. That seems like a pretty powerful way to build trust, even when there's no central authority calling the shots.
Exactly. And this diversity, it makes it way harder for just a few bad actors to manipulate the system. They use a pretty great example in the paper to explain this.
Okay, I'm all ears. What's the example?
They say, the probability of the Anti-Defamation League and the Westboro Baptist Church colluding to defraud the network is certainly much, much smaller than 20%. Like, two groups with totally opposite viewpoints are very unlikely to team up to cheat. It's the power of diversity in action.
Yeah, makes sense. It's like you're getting advice from people with different backgrounds, so you're less likely to be swayed by one, like, biased opinion. Okay, so we've talked about servers, ledgers, UNLs. Oh, but there's one more piece, right? The proposers. Who are they and what's their role?
Oh, yeah, almost forgot. Proposers, those are specific servers that are responsible for proposing, well, sets of transactions that they think should be added to the next update of that ledger. They're kind of like the team captains, you know, putting forward a plan for how the game should move forward.
Okay, so we've got our players, right? Those servers, and we've got our official record book, the ledger, and then those circles of trust, the UNLs, and of course the proposers, those team captains suggesting what should happen next in the game. But how does it actually, you know, all work together? Like, how do we know the right transactions get approved and everyone agrees on, like, the state of play?
That's where this Ripple consensus algorithm comes in, or RPCA for short. Well, let's break it down.
Perfect, yeah. Lay it on me.
Okay, so imagine you and your friends are trying to decide on a movie to watch, you know, for movie night.
Oh, yeah. That can get pretty intense sometimes.
Exactly. But you can't all just shout out your favorite, right? You got to somehow agree on one. So in the RPCA, each server is like one of your friends. They all start by proposing a set of transactions that they think, you know, should be included in that next update to the ledger. So it's their candidate set.
So each server has its own little list of like, hey, these are the transactions I think we should go with.
Exactly. It's their suggestion for, you know, the next move in the game.
Makes sense. But then what? Do they all just, like, start arguing about which transactions are the best?
Not quite. They share those candidate sets with, you know, the other servers that are on their UNL, their trusted circle.
Right. So it's like a conversation happening within those little groups.
Yep, exactly. And that's when the voting starts. So each server looks at the transactions proposed by, you know, the servers they trust and then votes yes or no on each one.
So it's like a mini election happening for every single transaction, but just within those trusted circles.
Yeah.
But how do they eventually make sure everyone agrees on the same set of transactions? Because what if there are disagreements?
That's the cool part. It doesn't just stop at one round of voting. They do multiple rounds. And in each round, they update their vote based on what they're seeing from, you know, the other servers that they trust.
Interesting. So it's not just like a one and done vote. It's this dynamic thing where they're constantly like refining their opinion based on what their buddies are saying. So does that help to like weed out any transactions that might be, you know, a little shady?
Yeah, definitely. Here's the key thing. To actually reach consensus, a transaction needs to get at least 80% of the yes votes, but only from the servers on a given UNL, right?
Okay, that makes sense. So it's like a safeguard, like you need a supermajority to
Yeah.
get something approved.
Right. It makes it much harder for just like a small group of malicious servers to hijack the system, and push through something bogus. So that 80% rule, that's how they make sure only the legit transactions get through. But how do they guarantee that, everyone ends up with the same version of the ledger, like the same scorecard for the game, so to speak?
Yeah, how do they make sure everyone's on the same page, literally?
Okay, so that's where the overlap between those UNLs comes into play. Remember how each server has its own unique UNL? Well, those lists are designed to have some servers in common. It's not like they're totally isolated from each other.
Right, so there's some crossover between those circles.
Exactly. And how much they overlap, that's super important for preventing these things called forks in the network. A fork, that's basically when you have the split in the scorecard, Two groups of servers disagree about what the transaction history should be.
Oh, I see. So it'd be like two groups of friends watching the same game, but they're each keeping score on a different scorecard. That's going to lead to arguments.
Yeah, exactly. Big arguments. But the RPCA, it stops this by making sure there's enough overlap between the UNLs. So if two groups, if they have enough servers in common, they can communicate and eventually agree on like a single version of that ledger, just one scorecard for the whole game.
So it's like having a few friends who are part of both groups,
Yeah.
right? Acting like a bridge to make sure everyone's, working from the same information. So even if some of the servers are being sneaky, as long as there's enough overlap, the system can still reach agreement, like having a neutral party to mediate and help everyone, see eye to eye.
Yeah, exactly. That's what's so cool about this system. It's not about trusting specific individuals blindly. It's about how the whole network is structured.
Mm-hmm.
That overlap between the UNLs, it's like a safety net to make sure everyone ultimately agrees on, the same set of transactions, the same version of the story.
This is fascinating. So it's not about like personal trust. It's about designing the system in a clever way so it's, resilient to anyone trying to manipulate it. Okay, so we've covered correctness and agreement, but what about utility? How do they make sure the system is like actually fast and efficient for everyday use? Because no one wants to wait forever for their money to move around.
Oh, yeah, you're right. Speed is super important here. Imagine waiting, days for a simple payment to go through. That wouldn't be very practical. So the RPCA is designed to be fast. Usually it can reach consensus in just a few seconds.
Wow, that's impressive. So no more waiting for like those bank transfers that take forever. It's practically instant. But how do they do that? Because those multiple rounds of voting we talked about, those got to take some time, right?
They do, yeah, but they happen really quickly. And the RPCA actually has some pretty neat tricks to handle those, slow or unresponsive servers that might slow things down. It's like, gotta keep the game moving.
Okay, so tell me about these tricks. How do they deal with the slowpokes? What are their secret weapons?
One thing they use is what they call latency monitoring. So the network's always keeping track of how long it takes each server to respond, to those messages. If a server is consistently slow, they flag it. And they might even, temporarily remove it from other servers' UNLs.
Ah, so it's like they're benching a player who's, slowing the whole team down. Makes sense.
Exactly. Got to keep things efficient. And they also have this whole system for detecting malicious behavior. Those sneaky servers trying to spread misinformation, like we talked about before.
Right, the bad guys.
If a server keeps trying to, disrupt things or push through those fake transactions, well, they can identify it and kick it out. Like, you're out of the game, buddy. No cheating allowed. It's all about keeping things fair,
So they've got systems for the slow players and for the cheaters. Pretty comprehensive. What about when, a new player joins the game? How do they know who to trust when they're building their UNL? Where do they even start?
That's a good question. So the system actually provides a kind of a default UNL for new users. Think of it like a recommended list, a bunch of servers that have a good track record that are generally considered reliable.
Ah, so it's like a starting point. Like, hey, here are some trustworthy folks to get you going. Especially helpful if you're, new to the whole game and don't know all the players yet.
Exactly. And the paper actually mentions a couple of other cool features that, make the system even more practical and robust.
Ooh, okay. You've got me intrigued now. What are these bonus features?
One of them is called network split detection. And what that does is it prevents a situation where the network accidentally gets divided, like split into two or more separate groups that each have their own version of the ledger.
Oh, I see how that could be a problem. It'd be like suddenly having two separate games running at the same time and everyone's confused about which one's the real one.
Exactly. Total chaos. So network split detection, it's like having this system that can tell if communication is starting to break down, and then it takes steps to prevent that split from happening.
So it's like a safeguard against accidentally creating two parallel universes.
Yeah, pretty much. And another cool feature is what they call multiple consensus rounds. It's a way to like fine-tune the process even further, and make extra sure everyone stays in sync.
Multiple consensus rounds. Tell me more. How's that work?
Okay, so instead of just having one round of voting, like we talked about, to decide on those transactions, they actually use several rounds. But each round has a higher agreement threshold than the last one.
So like maybe it starts at, say, 60%, then goes up to 70%, and then finally 80%, like raising the bar each time?
Yeah, exactly. And this helps the system like really pinpoint those slow servers. Because a slow server might be able to keep up in those early rounds when the bar's low, but then, as it gets higher, they'll start to fall behind.
It's like a race where the pace keeps getting faster, right? And only the fastest, most reliable runners can keep up till the end.
Exactly. So those slower servers, they get flagged, maybe even removed, just like with that latency monitoring we talked about earlier. It's all about optimizing the whole system, making it faster, more reliable.
Okay, so they've got systems to make sure everything runs smoothly, to prevent cheating, to help new players get started. It's really impressive, all the stuff they've built in. But I gotta be honest, after all this technical talk, my head's spinning a little. What does it all actually mean for the average person? Like, why should we care about this Ripple protocol and all its fancy algorithms?
Yeah, that's the big question, right? And that's exactly what we're going to unpack in the final part of our deep dive.
Okay, so we've spent like the last two parts of this deep dive really getting into the weeds of the Ripple protocol, and that consensus algorithm it uses. We've gone from those big picture challenges of building a decentralized payment system to all the little details about servers and ledgers and UNLs and all those voting rounds.
Yeah, we've seen how the RPCA, tries to solve this problem of trust when you don't have a central authority, making sure those transactions are accurate, everyone agrees on what's happening, and the whole thing runs, smoothly and efficiently.
It's been quite a journey. My brain's a little fried, honestly, but in a good way. But now I'm ready for the big takeaway. What does all this actually mean for the average person? Like, how's the Ripple protocol going to change our daily lives?
Right. Well, it offers this glimpse into a future where, financial systems could be way faster and more efficient and potentially more accessible for everyone. Think about it. Sending money across the world, like instantly, with almost no fees, no more messing with banks and all that. That's the kind of power this technology has.
That sounds incredible. No more waiting for those wire transfers or dealing with those, like, crazy fees. Yeah, sign me up. But how realistic is this? Is this something we'll actually see, anytime soon?
Well, the technology is here, and it's developing really fast. There are still, challenges to overcome, but the potential is definitely there. And it's not just about, like, individual transactions either. This could change the whole way businesses operate, especially the ones dealing with, international payments and stuff.
Okay, I'm definitely interested. Give me an example. Like, how would this work for businesses?
Okay, so imagine you have a small business, right, here in the U.S., and you need to pay a supplier in Europe. Right now, that's a whole headache, dealing with banks, exchange rates, fees, and it can take days for the money to get there. But with Ripple, that same transaction could happen like almost instantly. And for a lot less money, it's a game changer.
Yeah, I can see how that would be a huge deal for small businesses trying to, compete globally, get a level of playing field, give them access to better tools. But wouldn't this, disrupt the whole traditional financial system? What do banks think about all this?
It's definitely disruptive.
Yeah.
And the financial industry, they're definitely paying attention. Some of them are, trying to embrace this new technology, seeing how they can fit it into their existing systems. Others are, more hesitant. I mean, this challenges their whole role, right? As the ones controlling all those transactions.
It's like the old guard versus the new kids on the block.
Oh,
It'll be interesting to see how that plays out.
Mm.
But, it's not just about finance, right? this whole idea of building trust through a network without needing a central authority, that could have uses way beyond money.
Oh, absolutely. This could apply anywhere where trust and reliability are, essential. Think about voting, for example. Imagine a voting system built on this kind of technology. Secure, transparent, tamper-proof, every vote recorded on a public ledger so no one can mess with it.
Wow, that would be a game changer. No more, like, questioning election results and really empower voters. Are there any other areas where this tech could make a big impact?
Oh, tons. Think about data sharing, for instance, like in healthcare or scientific research where privacy is really important. A decentralized system could let people share information securely and efficiently, without giving up control of their data. Imagine researchers all over the world working together on, like, a cure for a disease, sharing data through a secure network. The possibilities are, endless.
This is, wow, it's like we're on the edge of this whole new way of doing things. But with any new technology, there are always, concerns. What are some of the potential downsides or risks with these decentralized systems?
Yeah, good point. One of the big ones is scalability. As more people use the network, as more transactions happen, the whole consensus process gets more complex. Researchers are working on making those algorithms, more efficient, but it's a tough problem.
So it's like finding the balance between security and speed and also being able to handle, massive amounts of data.
Exactly. And then there's the whole regulatory side of things. Governments and, financial institutions, they're still figuring out how to deal with this, how to classify it, how to regulate it. There are a lot of questions about, consumer protection, security standards, how to prevent abuse.
That's a whole new world, that's for sure.
Yeah.
So how do we make sure these new systems are developed responsibly? How do we get the benefits of decentralization, without sacrificing security and accountability?
That's the million-dollar question. It's going to take collaboration, between the people developing the technology, the policymakers, and the public. Everyone needs to work together to make sure these systems are used for good.
Feels like we're at a pretty crucial moment. The decisions we make now are going to have a big impact down the line. But I'm also, really excited about the potential here. It's like we're entering this new era where trust isn't based on, big institutions anymore. It's about clever algorithms and the power of these networks.
That's the beauty of it. It's this journey into the unknown full of, challenges and possibilities.
Right.
And the most important thing is to, approach it with curiosity, be cautious, and make sure we're building a future that works for everyone.
Well said. This deep dive has been amazing. We went from understanding the nuts and bolts of how Ripple works to, thinking about how it could change the world. It's been eye-opening, to say the least.
It's been great being here. This whole world of decentralized systems, it's constantly changing. I'm sure we'll have plenty more to talk about in the future.
I can't wait. Thanks for, sharing your expertise with us. And to everyone listening, thank you for joining us on this deep dive into the Ripple protocol. Hope you found it insightful and got you thinking. Until next time, keep exploring, keep learning, and keep asking those big questions.